Okay, we are live.
Hello, everyone, and welcome to another bi-weekly community call, FOAM community call. Today, we're joined by Althea, Jehan from Althea, and we're going to talk about, Althea, and then there's going to be some discussion surrounding what Jehan has talked about and some potential overlaps with the FOAM project. But before that, we will have, as always, a small 10-minute approximately intro/lobby mode. We also have Caleb and Trenton joining from the community, which is super nice, and we're looking to more and more have community members join these calls. But first, there's been a lot going on with the FOAM TCR and FOAM map this week especially, which has been represented in the staking contract and some of the challenges. Caleb, maybe you can talk a bit more about that.
Sure. So let me share my screen here and show you what's been happening on the daily digest. Kind of recently, what's happened is we have quite a lot of challenges for a pretty high amount of tokens. And these are pretty big challenges for pretty small defects. So it looks like in kind of reviewing the challenge transactions that a cartographer has been kind of double checking all of the points from having the most value to the least value and kind of looking for any error, kind of big or small. And what's been pointed out on the forum is, I think by user Foam Spacer and Noob and some other people, are that these challenges in some cases are quite minor, right? And so there's kind of been some discussion about if, having the wrong tag or maybe having the wrong phone number or something like that is worth a challenge for the entire amount. So in some cases where the minimum amount of tokens that must be staked in a point at the moment is 50 foam. So these are way above that minimum. We're getting challenged for the full amount. So it's kind of an interesting discussion that's going on about kind of what is appropriate for these challenges. But then what I can see also as a result of these challenges getting started is that the amount of tokens staked in the voting contract is actually reaching kind of all-time highs recently, and is growing quite quickly and quite substantially. So I see probably more interest, or what this indicates to me is that there's more interest from validators to use the platform and actually validate points and vote on points. One thing I'll just point out is that, towards this end of the proof of use period, there was also a lot of interest in the contract, and that was because a lot of points were being added and a lot of tokens were being used or being deposited in individual points as people rush to complete their proof of use requirements. And so it's good to see that, after that kind of proof of use period ends, the amount of tokens being staked in the voting contract is back on its way up. I think that's a really good sign. And just for context about the broader kind of staking in the all of the FOAM contracts, there are 3 contracts where tokens get staked. Right now, the signals contract is where the vast majority of tokens are staked. And then the registry contract comes next, and then the voting contract is third. So even though, there's a lot of growth in the voting contract, relative to how many tokens are staked in the FOAM system, it's not as many as are staked in the signal. So
yeah, it's interesting if you go back to the challenge list, that like the McDonald's challenge in Berlin currently has like the highest amount challenged, but also the highest amount of votes. But someone in our community that goes by the name of Jazz Hands was pointing out that they felt that was actually a really legitimate challenge because it's tagged as art and doesn't have a description or the proper website. And that this person painted a target on their back for staking so much in the first place. So some are minor details, and some seem to claim that these are the essence of challenges.
Yeah, it's been great to watch and great to listen to the discussion. So thanks for letting me share that.
Thanks for sharing, Caleb. As always, a lot of this information is pulled from the Daily Digest, which Caleb has produced previously. So those listening in or watching that aren't signed up to that yet, I'm sure someone from FOAM can share a link to the YouTube chat so you can sign up. As you can see, it's clearly a great resource for keeping track of what's happening on the FOAM map. So yeah, sorry.
Yeah, I was just going to say, before we get to Jehan, also building off the work that Caleb has worked on with us from Blocklytics on the leaderboard. I just wanted to speak to that, highlight that feature for everyone. I'm just going to share my screen for a second. Yeah, so this week we announced the FOAM leaderboard, also with integrations with 3box social profiles. And when we started out on this project, it was through kind of engagement with our community members. And one of them, CryptoZen, had proposed different ideas about gamification and had leaderboard as one. And we've seen some other projects like Veil and Super Rare and some others come out with leaderboards recently. And for us, we also wanted a way to have a social aspect to allow people to claim either their real identity or pseudo identity to kind of increase competitive spirit, and also show a way to have a sort of reputation so that you could see what's happening on the map. So this is the announcement post that Caleb had put together. And as you can see, we kind of wanted to highlight these 3box profiles and such as a way to build reputation. And so we've had this kind of discussion just now about challenges. And this is kind of part of an effort to expand the protocol activities beyond just the map. So we have the discourse, and then we have a daily digest. And from there, you can access the Etherscan link and see who's doing these challenges. And you can go to the leaderboard and see where they rank, and are they an active cartographer, are they active challenger, and maybe you could even find out who they were. And so this is something we're pretty excited about. And so there are 4 different categories that kind of measure. And right now we have 4 different leaders in each category. And so that is how many points you've actually added to the map, how many challenges you yourself have started, how many times you've actually completed the entire voting process, and then how many FOAM tokens you have actually earned by being a curator on the map. And actually, the kind of person who is that leader has earned almost $850 worth of FOAM tokens by being an active cartographer and curating the map. And this is kind of the aspect that we tried to highlight, showing how the FOAM map protocol brings a new aspect to open source mapping that OpenStreetMap lacks, where a lot of people add geospatial data, but they don't actually go back and check it. And then you have these centralized companies that are the ones checking the open source data. So it's really great to see this activity picking up. And so you can see the leaderboard here, and it's available at map.foam.space/leaderboard. And you could rank by different things. And where you see the 3box aspect is here. If they had a profile, you can do this hover and see who that person is. So we think that's a really interesting way to plug into 3box. We're really excited to work with them, and they're really helpful getting this to work. And it's just the start of kind of the leaderboard. As you see, we see it's still in beta. So we're going to be exploring new ways to highlight your collectibles and build out more ways to determine people's reputation that will really feed into these discussions about challenges. I don't know if you want to add anything, Caleb, about your process working on it, or anyone else on the call.
No,
it's something I'm pretty excited that we've launched.
Yeah, it's been great to work on, and 3box is a really cool project that we got to integrate, and the team there was really helpful in getting the profile hovers integrated and the data integrated. So that part of it was pretty smooth overall, and we're looking forward to expanding the functionality there. Yeah.
Cool. I'm just going to address a question that came in from our live viewers who wants to know how FOAM actually is different from OpenStreetMap, saying OpenStreetMap's free and FOAM involves a token. So first to start, the actual FOAM map interface, that is, the FOAM map is based on OpenStreetMap. We use the Mapbox SDK, which is kind of a framework for building web apps with a base map. And Mapbox builds on OpenStreetMap, which is open source data. But as I said, that data is contributed by open source cartographers for free, but it's not necessarily valid. So you have these centralized companies like Mapbox that actually check that data and have algorithms and package it for developers to use for web apps, and it's verified. So that's actually, we leverage that for the application. But for our purposes, FOAM is not to necessarily compete with OpenStreetMap, but it's to bring geospatial data onto the blockchain so that smart contracts can reference it without having to use an oracle. And so the first kind of type of geospatial data that we've addressed is points of interest specifically. And OpenStreetMap's really great with like roads and cities especially, but they're not the best at points of interest. And so points of interest kind of really dynamic because stores close and open all the time. And this is kind of a unsolved problem in the Web 2.0 space. But it's definitely unsolved in blockchain because there is no geospatial data there at all. So this is kind of the first step in a framework of bringing that data, and the first step in a kind of curation mechanism that's live on chain. And it is primitive in a way, but it is working, and at least people are experimenting with it. And there's an upgrade path that we can add incentives or more features. And as the blockchain ecosystem develops further and you might need more geospatial data, then maybe you could look to wholesale take something like OpenStreetMap and bring it into kind of a big data blockchain decentralized system where you actually have the roads and the polygons and the shapes and the whole map, which is like gigabytes and gigabytes of data, where right now the FOAM TCR just addresses points of interest and locations that could be referenced by applications. So as of now, the entire user experience is really aided by OpenStreetMap because that's actually the base map that we use. And we are sponsors of the OpenStreetMap kind of conferences like State of the Maps, and there's a ton of learnings from that community, and we hope to continue to engage with them.
Thanks, Ryan. For the next part of the agenda, we have Jehan from Althea, which we briefly touched on at the beginning of this call. Althea is a very interesting project in the blockchain space, and especially interesting for us at FOAM because there are overlaps in the idea of large overlaps of building these decentralized networks by local community building and by allowing people to set up physical nodes that connect and contribute to these decentralized networks. Without further ado, then Jehan, yeah, would be great to hear more about the project.
Yeah, hello everybody. Thanks for having me on. So I'll share my screen actually because I've got some visuals and stuff. So okay. So basically, what we're doing with Althea is we're trying to make internet access cheaper and faster using decentralization. And so to set the stage, I mean, you know, different people here may have different levels of internet access, but generally the US and across the world, developing world especially, of course, internet access is not what it should be. So I had to actually, I'll say the stats. So in the US, for instance, you have like 35% of the internet connections that people pay for in the US are like slower than 25 megabits. And a lot of those are slower than 10 megabits. It's slower than 10 megabits, you know, that's like crappy DSL. You really start to notice it. That is, as far as we can tell, and kind of the thesis that we based our project on is that is due to the fact that it takes a lot of coordination and kind of infrastructure to supply internet access. And the way it generally works in the world today is that you'll have an ISP, and the ISP supplies internet access to people. That's homes, businesses, even cell phone towers. And this ISP will generally own a network. They'll own a last mile network, so they'll own a lot of wires on the telephone poles or wires underground, or radio, like radio equipment, and we specialize in radio equipment. And so the equipment we use is, I'll get a little bit into more what we do, but the equipment we use is also used by wireless ISPs. It's this pretty big industry. And when you're talking about internet access, technologies like cable, like coaxial cable, they can go up to maybe 50 megabits. DSL is generally, DSL in theory can go very, very high, but the capacity of the phone lines that exist right now, it's generally limited to 15 megabits. An equipment like this is Ubiquiti's site, for instance, we use this stuff. These guys can easily do 100 megabits. And this equipment, like this nano beam or light beam here, these are both models that we use in our networks. They're about like $100. And then this stuff that's these more kind of base station type equipment, they're maybe a couple $100 up to $1,000 for really good stuff like a pair of these down here is air fiber. They're about $1,000, and those let you do like multiple gigabits over many miles. So wireless internet access is actually it's a fast growing segment, and it can deliver great speeds to customers, especially in places where there isn't the will or the ability even to lay fiber. For instance, in rural areas or in places in the city where they simply can't get the internet. It's much cheaper and faster to set it up with wireless gear. Anyway, what does Althea do? So basically, what we're trying to do is using decentralization and blockchain as our tools, we're trying to make kind of almost, you think of it as almost like an Airbnb-like model, where if you host a piece of this wireless equipment on your roof, then you can earn money by forwarding packets to your neighbors. So let's say you're hooked up to an Althea network and you decide that you can actually see like 50 other houses. Let's say you're kind of on top of a hill or something like that. You can see 50 other houses that aren't on the network, or the organizer of the network told you they're not on the network. And so what you can do is make an investment in, buy some of this little slightly more expensive gear and set that up and point that at the houses. And then if they get onto that local Althea network, they're going through you, and you're going to be earning money. So that's kind of the basic goal. And what we've noticed is that in ISPs, there's actually a lot of the cost is from coordination and also real estate. So if you're trying to lay cables and stuff, that's extremely expensive because you've got to dig up the street, you got to deal with the municipality, or you got to deal with telephone poles, also very expensive. And then also if you're doing wireless stuff, it's still expensive because you've got to deal with trying to figure out where you can put this stuff. And oftentimes, the places that are available in advertising their real estate as a place to put a piece of gear, they're also being used by a lot of other people, and so it tends to be kind of expensive. So with Althea, we're trying to make it so the customers also provide the infrastructure and are rewarded for it. So yeah, basically the way I'll get into how it works as well. So the way it works is firmware. This is a little bit of the basic level. We'll go a little deeper than we go on this one for you guys. But basically the firmware allows the routers to pay each other every 20 cents about they just pay each other for the bandwidth they use. So if I'm connected to you and I'm downloading a movie or something, then I'm going to be paying you effectively as that movie downloads. And so for the end user, what they do is, here, this diagram's kind of good here. So the end user does is they put money into their router, and that money is at this point in time is DAI. So they get the stable coin, they buy it, they put it into the router. There's a dashboard and stuff, which shows them how much they have, how much they've used, etc. And then so somebody who's hosting a relay node is what we call it on their property, on their roof or whatever, is also earning some money. And then there's also the uplink or backhaul, what we call it, which is the connection to the internet. Oh, you know what? I realized I just forgot to touch on something else with the so with the connection to the internet. You might be wondering, if you need a connection to the internet, then how does that work? Why do you need to buy a connection to the internet? And if you're already setting up an internet network, so basically, a last mile ISP goes to homes and offices and stuff, they'll buy internet connectivity from what's known as a tier 1 ISP. And these are the guys that run these fibers across under the ocean, across the continents and stuff like that. And that market is actually relatively more competitive than the last mile market, because you'll have like different, if you're at a place where you can get, so it's not, obviously you can't get tier 1 everywhere, and the role of the last mile is to spread it out to people's homes and offices. But basically, it's cheaper, it's competitive, and it's a better market than the last mile.
So, Jehan, how does Althea really interact with tier 1? It kind of like plays nice with it and ultimately relies on these kind of like undersea cables.
Yeah, exactly. So the way it interacts is basically Althea will, we have different names for different components of the network. So there's gateway nodes, relay nodes, and end user nodes. They actually all run the same software, but they're kind of playing different roles. So a gateway node is someone who is paying for this tier 1 bandwidth, and that generally costs anywhere from $500 to $2,000 for a month for a gigabit of bandwidth. But you can service a lot of end users with that. And so an Althea gateway node will basically be connected to an Althea network, and is basically taking traffic from that network and putting it onto the internet. And you can have any number of gateway nodes in a network. Our networks right now each only have one, though. That's how it interacts. So it interacts with the tier 1 providers in the same way that any other last mile internet provider will interact with them.
Well, thanks for the insight.
And so yeah, so you can see here, I mean, people have hooked up their houses. Obviously, this is a greatly simplified little town, but they've essentially hooked up their houses with this radio gear, and so these guys here are end users. These ones over here on the right, and then here's the relay on the top, and the gateway is on the left. It's a very simple schematic diagram of that. Then on a deeper level, how the protocol actually works on a technical level is that so number one, there's the micropayments for bandwidth, and those we're doing them now actually on chain, but we'll probably switch to some scalability solution as we need it. But actually, we're going to be using Cosmos. We found that that's actually going to be pretty scalable. But payment channels, for instance, we've also done a lot of work on that. That might be a good route to take. But basically, there's that, and then there's the other thing is the routing protocol. So the routing protocol is software on the routers, which decides. So for instance, this I don't know if I have a good example here. This is actually a pretty tree-shaped network. But if you have multiple paths through a network, your router's got to know like where to send packets to get to the destination. And in this case, the destination for an end user is going to be to go to what's known as an exit node, which that's a little bit deeper. It's like a VPN basically that takes your traffic and puts it onto the actual the public internet. Gateway nodes then connect to those exit nodes. But anyway, you're routing to that, and these routing protocols are, of course, how the internet works. They're how any last mile ISP works usually as well. But we've added a price metric to it. So basically, your packets are going to take the cheapest and best path. And so that really comes into play when you've got networks that are more interconnected, where there are multiple paths through the network. It's automatically going to choose the best path. So I think that's kind of a basic overview of how it works technically. Do you guys you think I should get into a little bit more of the? I guess what point in the roadmap are you currently at? So right now, where we're at in the roadmap is at this point we are sort of pretty early, to be honest, and we're just helping people set up Althea networks. So we've got these case studies here. This is Oregon. This network's actually run by my co-founder, Deborah, and she's got, I think, about 25 users on it now. And you can see here is this is a map of her town, and it's in Clatskanie, Oregon. And so they set up all this gear here. And for instance, this is setting up a tower here that's on a hill. And so basically her computer shop in town is the gateway, and she has a fiber access there. But a lot of people in the surrounding areas have very poor internet access. Some of them have to use, before they were using Althea, they had to use their cell phones only for internet, and it was very expensive for them. So then I'll show you the other case study here. This is, get back to it. So in Medellin, they've also got a network, and that's not run by us, that's run by a group in Medellin. And it's in a neighborhood that's called Comuna 13, which is a neighborhood that's on a hillside. It's and generally in Medellin, the way it is, you can see here in this picture on the left, behind these people, you can see the more interior of the city of Medellin, where skyscrapers are and stuff. And that's the richer area. But in the hills surrounding it, so you can see here, they're on a hill here, and then also even in the background there, you can see on the other side of the valley. That's where the poor neighborhoods are, and they traditionally have not had very much infrastructure at all. Even it used to just be like mud hills, and the municipality has done great work in the last 10, 15 years of putting stairways and stuff like that. But generally, it's pretty inaccessible, and housing there is cheap because it is very inaccessible. It's also a very beautiful place. So here you can see some of the environment here in this picture. You've got all these houses on the hillside, and so there we helped the group set up the infrastructure, and it comes from a school, which is here on the map. The school's actually linked back, it's not on this map, it's linked back to fiber that's in the center of the city over a long-range radio link. And so then it's got, you can see here, it's got antennas that point at the sector antennas. These are like more of the base station type, which point at the rest of the neighborhood here. And then, let me see here. So then you can see here's an example of an intermediary node. This is at the house of a guy who helped set a lot of stuff up. He named Mario. But basically, he's got this in his window, and then he's running outdoor Ethernet cables to his neighbors. And so he's reselling this connection he's getting from the node that's on the school. He's reselling that to his neighbors. So yeah, so the stage we're at, to sum it up, is we're always fielding inquiries from interested people, but it's still very much a trial stage, and we're ramping it up right now. We've got a lot of the software finished, and we're ramping up to help more people start networks. So generally, if you're going to start a network, you're going to want to get to break the threshold to where you can get that backhaul, which is that $500 to $2,000 a month. You want to have enough users, and so we're also developing tools to help people kind of get people pre-registered and get to that threshold.
I have a question regarding, so these networks are already up and running, and you said that the payments are running on mainnet already. How is the price currently defined, and how will that change over time?
Yeah, so just to clarify, the network in Klatskina is still it's running on the Ethereum mainnet, and it's using Ether because that's kind of what we started with, and we don't want to switch everyone over, but we'll do it soon. The one in Medellin is we started directly on XDAI, and that is, of course, going to switch over to Cosmos, but there's still work to be done there on the bridging of DAI over to Cosmos and other things. But yeah, the way the prices are determined is interesting, because in theory, and in practice too, intermediaries can set the price that they want to charge. And the way it works is, as you go through the network, so this gateway might be charging 10 cents a gigabyte, and the relay might be adding another 5 cents onto that and making 5 cents profit per gigabyte from its neighbors. And now you can remember, the relay just had to pay for like for a few $100s of equipment, whereas the gateway needs to pay for this big expensive subscription. And so often the relays will charge less because of that. And that's going to add up to this guy here. That's going to add up to 15 cents a gigabyte. And so if they're adding another 5 cents on, these ones here at the edge are going to be 20 cents a gigabyte. And however, let's say this one here is paying 20 cents a gigabyte, gets a direct link up to this other one connected directly to the gateway at the bottom. They're essentially going to bypass this one in the middle, but depending on what the availability is and stuff of the other node they're connected to, what the network conditions are. And so they're going to be able to get a cheaper price. And that's kind of where the routing protocol, the price measure comes in, is to try to give people the incentive to kind of arbitrage bandwidth. And the way that relays will set those, right now, it's set manually. So you can say, I want to set 5 cents. But we also provide, we want this to become an ecosystem of pricing plugins, because there's actually a lot of different ways you could approach it. You could use economic theory, you could use machine learning stuff, different ways to optimize the amount of money that a relay is making if they're in a network. But right now we have one pricing plugin, which is where we just set the price remotely. So, but we like so that people don't have to set it themselves. We'd like that to grow into a little bit more of an ecosystem once there's, once people, it's obvious you can save people a lot of money with a good plugin. Then I think that's going to be what we're going to want to work on. Did
you speak to how engaging like rural versus urban testnets are differ in your approach?
Yeah, I think the big. So there's several. There's definitely a lot of differences in rural versus urban. The first big difference is it's going to be the obviously the type of network you're setting up and the type of equipment that you're dealing with. So these guys here, Ubiquiti, they've actually done a great job. This diagram on the site of kind of capturing that. So in the rural scenario, you're really going to be worried about the range. And so Deborah, for instance, she's got people who are miles away from her computer shop who are directly connected, and that's pretty easy with 5 and 2.4 gigahertz equipment. That's actually also the frequencies that Wi-Fi uses. It can definitely do that distance. Line of sight is still a concern. You don't want to be going through too many trees, or you obviously can't have mountains in the way and stuff like that. But that's one big factor. Whereas in the urban environment, you're mostly concerned about, how do you avoid noise? There's a lot of other people running other radio stuff in an urban environment, and then also you're generally dealing with much shorter distances, but your paths are going to be more complicated to get to where you're trying to go if there's a building in the way or something. And then there's also economic differences though. So in a rural environment, a lot of the time, so in a rural environment, people, a lot of the time, people do not have good internet access already. And so that makes it a lot easier to sell, of course, if you have a good solution. But it's also, there's less density. And so you're not going to be able to come in and capture, hundreds of users within a square mile or something. It's going to be a lot more spread out. So that's a factor. Whereas in the urban environment, of course, a lot of times, especially in the US, people have other options. So you're going to be competing more on speed. In Medellin, that's different though. They don't really have other options there. So in Medellin, it's more of a thing. The density's been really useful. Because people have been able to connect to their neighbors just with wires, which is kind of easy, inexpensive, and also the fastest way to do it. But yeah, I would say density ultimately is the main difference.
We have a question from the live stream asking, how does this compare in cost and return on investment versus traditional ISP, and especially as a tier 1 Althea node? Why use this for setting up a central ISP for that location?
Yeah, so that's a very good question. So if what we're trying to target is if somebody has, it's also interesting. There's also a big difference here that we've noticed since we have had the opportunity to have this deployment in Medellin, which is more of it's a very different context in the U.S. But yeah, in the U.S., if you're running intermediary node, you're going to want to be serving. You're going to want to be serving. You're not going to make a huge amount of money on every customer that you have, because most of the money's got to go to the gateway. So as an intermediary node, you're going to want to be serving like at least 20 clients, because then you might be making $100 or $200 a month, and that's probably, to me, I feel like that's the threshold at which it's worth the effort for people to do this and really pay attention to it is when it is a little bit more of a significant. If you're making, if you're making $10 a month, you're not necessarily going to take it very seriously. And then Medellin is a little different because people don't have they don't have a lot of money, and money is generally is worth more, and people also have more I think iterant in employment, and so if they can have something where they can earn a little extra money on the side, that's great for them. So there, it's actually been a lot more viable to have intermediaries that only have a few clients. But to address the tier 1 thing, so if you're a gateway and you're paying for this tier 1 internet subscription, the reason you want to use Althea over setting up your own network is that we haven't proven this out yet, but we believe that it will be more profitable and easier to grow the network if you are if you're using our technology, because you have the built-in viral growth of people hooking up their neighbors and having the incentive to hook up their neighbors, and so it's not just going to be you driving around in a truck all day installing customers and having a complaint. It's a little bit more ownership in the community, and so you're a part of the network, but you don't have to control the whole network, and that's kind of a burden off your shoulders. And I can also get into here, we have the subnet DAO concept, and I'll probably get into that more later, but I'll touch on it briefly here. So the concept of the subnet DAO is it's a group of people who are essentially getting or we call it more subnet organization now. That was a little bit technical. But they're getting a fixed cost per router that's on the network. They're getting a fixed fee for the IP address. And so they're incentivized to have more routers out there, whereas the gateways are just selling their bandwidth. So in a more mature Althea network, what we'd like to see is that you have the subnet DAO kind of going out there and doing a lot of the support and a lot of the promotion and stuff. And then as a gateway, if you're getting that tier 1 connection, it's much more of a simple mathematical thing. You realize you can sell this many gigabytes of data into the network, and you can get that backhaul for X dollars per month. And so in a more mature network, it will be hopefully a little bit more decentralized and spread out, where someone's just acting as a gateway node just because it makes economic sense. But right now, in both of our networks, also in the networks that people are planning, the role of the first gateway and the subnet DAO is like the same. It's the same people, because obviously you've got to get the network up and running. Did I answer the question?
Yes. I had a question regarding the subnets and Aragon and TCRs.
Yes.
Which is maybe more futuristic, but very interesting.
Yeah, go ahead.
Well, the question is, how will you implement that in the subnet DAOs? I understand for governance, and maybe you can talk a bit more about that.
Yeah. So I've let me actually let me pull up our. I'm going to see if I'm gonna see if let's see. I hope I'm going to select the right one here, but I'm going to see if I can get our latest designs. I have some in my slides. I have some very old designs of the subnet DAO interface, but I think I can get some more recent ones here. But basically, oh, that's the wrong one. Okay, sorry. I should have gotten this lined up beforehand. So in the okay, so in the let's go to the old screenshots here. They'll get the point across. In our model, basically, you have something we call a subnet organization, or a subnet DAO is kind of the software they use. And so basically, this is a list of Ethereum addresses paired with IP addresses. And for routers, they look at this, they know which one they're on, and it's just a list on the blockchain. And when they connect to another neighbor, they check whether that neighbor is on that list. And so if your router is not on the subnet DAO, you're not going to be able to connect to the nodes on that network. And And of course, they're also performing the function of giving out the IP addresses, which of course avoids collisions, avoids two people having the same IP address or something. But the main role is like, the main role is to kind of have this network that's curated to keep out bad actors, and then also to be able to collect a fee. And so
maybe it's not the headphones; it's really just chalk.
Ryan, you're not muted.
So a subnet DAO, basically, there's the software associated with it, but it's really just more for administration. And of course, the fees that are coming from each router that's on this list are going into the wallet of the Oregon app, and that group who administers it can then use it, use that money, spend it on things, pay installers, for instance, or pay for promotion, pay for support, stuff like that. In the global TCR, we haven't done a huge amount of work on this right now, because we're really just focused on kind of, this is going to more come into play once there are a lot of subnets out there and people have to choose which one to use. Right now, of course, we just have a few networks. We don't have any networks that are directly competing with each other or anything like that. And so the global TCR could also be something that's another type of voting structure or governance structure on the blockchain. But basically, that is to approve which subnets are good. So that's essentially going to be which subnets don't have any complaints about them and are providing a good experience to users. Similar to the point of interests, it's a binary thing. So if you're up to the standards, then you can be on the global TCR, and it's really quite similar to a franchise model. So like McDonald's. So if you're running a McDonald's, they're giving you a lot of help, but then at the same time, you've got to your restaurant's got to be up to the standards and meet the inspections and stuff like that. So that's kind of how that fits together. Does that explain it?
Yeah, that's great.
Yeah.
I would like to jump under the hood a bit into the scalability in Cosmos, but we just have one last question, or not last, but we have a question again, follow-up about what happens if a gateway peaks at capacity? How does that affect the mesh that's reliant on it?
Yeah, so if a gateway hits its capacity, then it's just going to, I mean, people are going to, get slower internet service. And this happens all the time in existing. This hasn't happened for us yet because our networks are pretty small, but it happens all the time in conventional ISPs. It really depends on how how good your ISP is, but basically it can certainly happen. And when you have complaints about your internet, or got crappy internet, or it cuts out or something randomly, or it's slow randomly, that's usually what's happening. Either nodes that are in the local last mile network are hitting capacity, or their backhaul is hitting capacity. And so with the price aware routing protocol, that provides a very good incentive for, if that keeps happening a lot, that provides a very good incentive for someone to come in and start up another gateway and sell that bandwidth into the network. And the other thing is, though, if you're running a gateway and you notice that you are hitting capacity, there's a little bit of more of a direct incentive, just due to our billing is per it's per byte. So there's a little bit more of a direct incentive for that gateway to then to get more bandwidth and to up their subscription, basically, because they're going to be selling more data. At the end of the day, they're going to be moving more bytes and earning more money if they're able to keep the quality high, because people are going to be using more data. Whereas in the business model of most traditional ISPs is this quote unquote unlimited, and so for them, they basically just want to keep service to the point that people aren't completely like rebelling and switching their ISP totally, or getting really mad and going online. But in Althea, it's a little bit more smoother and more granular, where there are incentives built in to keep the service at as high of a level as possible.
Thank you, Jehan. Ryan, you asked something about, or you wanted to discuss the Cosmos scalability.
Yeah, so I mean, you mentioned earlier that your ultimate plans are to kind of shift over from the Ethereum mainnet, and you found that for your purposes, Cosmos is a really good option. Could you maybe speak to how you plan to utilize it? Is Althea going to be its own zone that relies on the hub? It's going to have its own validators, and maybe just what really brought you guys to Cosmos?
Yeah, so I think we've so what brought us to Cosmos is that they at the time we were planning all this out, a year and a half ago, Cosmos was the most kind of the most advanced or the closest to shipping kind of next level blockchain solution, like scalable blockchain solution. And of course, it took them a lot longer to ship than we thought it was going to. But they are still obviously they have shipped now. It's not completely finished yet, but they're live. And I suppose EOS is live, but EOS is kind of a weird, it's kind of a strange beast. So Cosmos has a pretty simple sharding scheme, I guess you could call it, which is that you have these zones. And so for instance, we'll have an Althea zone, and that Althea zone is not sharing capacity with everyone else using Cosmos, and so it's it's more scalable. Other blockchain projects, other next level blockchain projects like Polkadot or Ethereum 2 even, they're doing more of a sharding thing that's more like thread based, where it's actually still all kind of sort of like one chain in a way. And that in theory maybe is a little bit more smoother and easier to work with, but it also is more technically complicated. So that's why we chose Cosmos. We will be running an Althea zone. That's not up yet. They just obviously got their stuff working like last week or something. So we're going to run an Althea zone, and basically the way it works with Cosmos is we're going to have to go around and we're going to have to get the Cosmos validator community, find people to validate our zone, and they'll be running the proof of stake nodes. They'll sort of like miners, and then we are going to have a token called Althea governance token, and this is separate. This is not used to pay for bandwidth. DAI is used to pay for bandwidth, but the Althea governance token is staked. Is delegated to people who are running validator nodes, and so people with the token are earning transaction fees and also earning fees from the governance system as well. And what we will be able to do, we should be able to, doing the math actually, even if we're not using payment channels, we should be able to do like a very large number of end users on one Cosmos zone. But then we can also shard it out even more. Our networks don't have to interoperate with other networks, with other Althea networks very much, unless they're kind of bordering them maybe. And so we can probably shard it geographically. And if we need to in the future, have several Cosmos zones, have a US Cosmos zone, have a European one, or even further sharded than that. So yeah.
So that's kind of going to be a different class of actors in your system, that you have dedicated validators for your zone. You're not going to be relying on the security of the hub validators. So you'll have people that are separate from the gateways actually producing blocks and verifying things.
Yeah, I mean, we've learned a hard lesson in the blockchain space, which is that we don't use things that are not yet in production.
Yeah, for sure.
Yeah, the Cosmos hub actually does have some other security benefits. For instance, zones can checkpoint states into the hub to prevent kind of long range attacks. They can say it's definitely, the hub is certifying this was the state. These were the block headers at this time, which adds some security. And there's also some stuff where validator nodes, if you can present proof basically that they have cheated somehow in the in the protocol of a given zone, they can get slapped on every zone. So there's definitely these larger security benefits that come about because of the way the Cosmos system as a whole is constructed. But at this point in time, with what's in production right now, we're mostly looking at and we're focusing personally on like getting people validating. And then also building a bridge from mainnet Ethereum DAI into our zone, so that people can use the DAI tokens in our zone.
Maybe we can move past the screen share section.
Oh yeah, sorry.
Trenton, you had a question, I think?
Yeah, I was just curious. First, thanks for giving us a little bit of a deep dive. I haven't kept up as much on Althea as I would have liked, but good to get an update. I'm just curious how you imagine the subnet DAOs communicating with Cosmos, and you just mentioned that the DAI would be bridged. So would that be a similar mechanism? How you bridge the governance mechanism for those local subnet DAOs?
Yeah. So, okay. Yeah. So the governance mechanism for the local subnet DAOs, they are just, I mean, they're going to be running on our Cosmos zone and doing their thing. They've got a list of IP addresses and you know, it's relative in a multi-sig wallet kind of thing, relatively simple. And then the governance structure is a list of subnet DAOs. And so if you're not on that list of subnet DAOs, similar to the point of interest map, you're not going to be showing up if people are looking for a network to join. And you're also, we might do something a little bit, we're not sure if we're going to do this or not. We might do something a little bit harder as well, where the standard firmware will not even join a subnet DAO that's not on the global list that's curated with TCR. So that's how that works. That's very different than the bridge. So the bridge from DAI on the Ethereum mainnet to Cosmos is what also they're known as pegs. And that is going to be something like, basically, if you lock up some tokens, some DAI, you send it to our contract on the Ethereum mainnet, you lock it up there, you're going to have some effectively Althea Cosmos DAI minted in our zone. And then you're going to be able to use it there. And then if you send that DAI back to the contract in the zone, it's going to get burned and it's going to get unlocked and sent to your account on the Ethereum mainnet. And that's kind of how that peg works. And that's similar to how, so like right now we're not using that, we're using XDAI right now, and XDAI has a peg that works just like that. So yeah.
So I guess that sort of answers it. What I meant was, I guess Oregon isn't deploying on Cosmos, so there will have to be, when you have addresses receiving DAI for the services that they're providing, that has to go back through the peg to the Ethereum mainnet to interact with whatever these DAOs are.
That's still in development, honestly. But that is an option to go through the peg like that. But that's rather complex, a lot of moving parts.
Yeah, no,
that could be done. The other thing that we could do is, so Cosmos has a thing, again, also not in production right now, called Ethermint, which lets you run EVM code on a Cosmos zone. And so we could also just deploy all of the Oregon code on Cosmos and have it run there.
Cool. I have a question. How do you think that basically the FOAM location project and offering fault tolerant, time precision could benefit Althea? I think we've spoken in the past about like symmetric routing versus asymmetric routing. Are there other use cases, or how do you think if these protocols would coexist?
Yeah, that's a great question. Thanks for asking. So yeah, with FOAM, it's a very exciting project, and I think that I'm excited about something that, like you mentioned, that people don't actually pay a lot of attention to with FOAM, which is the fact that your system, in order to provide proof of location, it also has to provide a consistent time across across the whole area that FOAM is operating, and that's really cool because that actually is something, people may not realize it, but that's something that doesn't really exist, consistent time, unless you've got atomic clocks. And in networks, there's like network time protocol, which has a huge amount of kind of adaptive, like fudging and different things that it does to try to keep different servers in sync with time. But the basic difficulty that comes about is that you don't know what the latency is between you and somebody else unless you measure it. And, you can't measure it if your clocks are different. It's a chicken and egg problem. And so because of that, so in our routing protocol, it's actually a patch on Babel, which is a routing protocol that's been around for a while. But in Babel, basically, you can have different metrics. So of course, the price metric is important to us. But there's also the other two main metrics, I would say, are a packet loss metric, which basically says, hey, I sent, if I'm sending packets to this other node, how many get lost? So in a routing protocol, that gets added up basically. If I've got 10% packet loss to Ryan, and then Ryan is connected to somebody else, and he's got 10% packet loss to them, then if I'm trying to go to send packets to that other person, then that's going to be 20% packet loss, maybe. It's not quite like that exactly, but that's the principle basically. So the routing protocol kind of sums that all up on every hop and figures out what the best path is to a given destination that way. There's also latency. Latency is also, I mean, packet loss and latency are like the two important aspects of your internet experience. And so with latency, right now, the thing is, if you're trying to measure the latency between you and another node, you've got to measure the round trip time, because you can only trust your own clock. You don't know what their clock is set to. And so what that ends up resulting in, and I won't get into kind of the overall model of how routing protocols work, it's kind of complicated, but what it ends up resulting in is that if you're trying to route to somewhere else, you're only gonna be able to figure out what the best path is in both directions. And so you might have somebody who is there might be a node in your path that's got pretty good latency in one direction, but not very good latency in the other direction. But you're basically only going to like kind of choose based on the average of what their latency is in both directions, because at every step is just being measured as round trip time, and that's symmetric routing. But you could have it might be a lot better if you could have asymmetric routing, where your packets are choosing the best path to another node and the best path back, instead of having it be a path that's kind of okay for both sides. And that will be made possible by FOAM. So if you have if you have nodes that are running clocks that are all synced up to each other, then you can measure it individually, because you can send someone a packet and say, hey, what time did you get that packet? And you're going to know that their clock is the same as your clock. So that'll be good for Althea, but also just routing in general. I think it's going to be pretty exciting once people start integrating that into routing protocols.
Great. This has all been great. I know we're nearing the end of the call. I personally have one last question and see if anyone else on the team does. But Althea is kind of really specifically tackling this last mile internet problem in really unique ways, and similar to FOAM in some ways, taking existing tech and kind of repurposing it and giving an incentive model, which is really great to see. But as we know, there's kind of like a plethora of other efforts towards bringing internet to either last mile, but I'm looking into FOAM, looking in like the low power, wide area kind of network space. There's like an arms race to provide internet to IoT. So you have things like LTE-M and NB-IoT, which are telecom license spectrums. There are projects that are somewhat similar to FOAM, like Helium, that are using their own open protocols to provide internet to IoT. And we have also just these like other kind of like even LoRa, for example, somehow can transmit packets for IoT. Do you see Althea eventually kind of branching out beyond last mile and being a kind of alternative for lower data packet rate kind of transmissions for these devices?
Yeah, so I think that it's an interesting question. In some ways, Althea is very well suited because you're paying per byte, and so that's a very good match for an IoT model where if you have some sensor, you're not necessarily going to want to pay for obviously like a whole cell phone plan or something for that one sensor. That doesn't make any sense. So a bunch of sensors could easily connect to an Althea network and pay as they go. There are some roadblocks in the way of that in our routing protocol right now, which is that basically every node in a network needs to have enough memory to know about every other node in the network with most routing protocols, including ours. So if you have a huge number of nodes, that could be a problem. There are improvements we can make there if we were to really get into doing our own implementation and doing a lot of efficiency improvements. We can bring in pruning and stuff like that to be able to handle more devices. Another thing is also micropayments. So we want to have something a little bit more robust for micropayments. We're going to bring a ton of devices in. Channels have a lot of limitations around the fact you need to capitalize them. and the fact that it's difficult. There's stuff around that might make it difficult for devices that really only want to pay a very small amount to use channels. And then another thing, it's a little bit kind of it's sort of a fuzzy parameter here, but there's kind of a difference between network technology that's made for dealing primarily with client devices versus network technology that is going to take part in a more interconnected network. So, for instance, if you have like a client device, a lot of the time, a good way to handle a client device is actually going to be to say that the protocol between like that last hop, basically, the very last hop, the protocol of the last hop is different than the protocol that carries the packets to the network. And you see this with Wi-Fi hotspots, where you've got Wi-Fi, you've got a username and password and MAC address and stuff like that, and that's a different protocol than the routing protocol that's actually taking it across town. And the big difference there is being able to handle a lot of clients versus every client being able to reroute traffic in the network. And so there's some overhead with loop avoidance and stuff like that. It's a little bit too much to get into here, but for that reason, it's like pretty technically different actually to make something that works for a lot of devices. And so we focused on the last mile, because even if you have, like, let's say you have another IoT protocol, Helium, let's say, a Helium router, you plug that right into source of Althea bandwidth, and that'll work great. And they're using a protocol that's kind of meant for IoT. So that's how I view it.
Cool, great. We have another question that's come in from Decentralized to Dan, great name, asking if FOAM and Althea are both on Cosmos, does it make it easier to benefit each other? I'll take a stab and say, well, maybe, but I think that the benefits might actually be, from the non-blockchain aspect, actually like over the air, like radios, and that the synergy might happen more in the radio space than necessarily because we both would use Cosmos. Although it might be less latency to cross-verify a zone, if a zone is a valid zone or something, or can we trust this time? It might be quicker to check, but I think that the benefits will actually happen over the air. I don't know what you think, Jehan?
Yeah, I think so too. I think with Cosmos, once they build out kind of a lot more of their stuff that helps zones interact with one another, there might just be places there where it does make it easy for us to just pull one of the libraries out and use that somehow. For instance, transferring tokens or something like that. But that stuff's not ready yet, Cosmos, right now. So yeah, I agree.
The follow-up question is about if we have like synergies to our project, how would we potentially share roof space? And I think that kind of also speaks to overlap of potential community building. The theme of this talk was how to make decentralized community building. And what's great about Althea and FOAM is that you can actually get involved in the real world and potentially meet people. I always imagined one day, there can be a device that packages multiple protocols that's, for consumers, whether it's Althea, FOAM, and a Filecoin node or something. But I definitely think, scouting locations and finding the people who want to participate in such protocols probably has a lot of overlap.
Yeah, I agree. I think a big piece of the overlap definitely is the social aspect. So if somebody is into this kind of stuff and they also want to earn money through these protocols and they're willing to kind of get up on their roof, that's a big factor. So with a FOAM node, you're going to need to have a steady power source. You're going to need to have, I think the requirements are a little bit relaxed because you're dealing with a much lower bandwidth requirement on radios, so you don't need as much line of sight and stuff. But certainly if you've got, I can definitely say that if you've got an Althea node installed, any Althea node is going to be a great place to put a FOAM anchor. Whereas not every FOAM anchor is going to be a great place for an Althea node because it might not have line of sight and stuff like that. But I think there is a lot of possible synergy there. If we packaged FOAM nodes with Althea equipment, I think that they would be able to run pretty well anywhere Althea is installed. There's also synergy with solar too, which we probably haven't explored enough, just because it's also on the roof.
Yeah, definitely. Well, there's a lot of exciting potentials. I'm really happy to have you on and share your updates with our community and a lot of learnings. I'll open to just see if anyone else has some final questions. Any of you guys on the call?
I think that's a great way to end.
Great. Well, thank you everyone for tuning in, and everyone who contributed as part earlier in the call.
Thanks everyone.
Thank you,
Thanks,
everyone.
Jehan.
Thank you.
Bye.
Bye.